Okay, so we are going to learn in this set of guided notes how to simplify nomials. And so we're going to go over some vocabulary and give you some examples really fast. And then I'll tell you why you should even care about knowing how to do this. And then we will go over some example problems. So the first thing that we're going to look at is something called monomial. And monomial is an algebraic expression with exactly one term. So examples of monomials would be 3x squared. That is one term. So when we think of term, we want to think of a coefficient, a base, and an exponent. A coefficient, a variable, and an exponent, or just one thing. Okay, so no addition or subtraction in between. Another example might just be x cubed. That's just one term. It's one component. We have no addition or subtraction surrounding it. You could literally be anything. It could be 1/2 x to the 6. Okay, these are all individually monomials. A binomial, if you think of like a bicycle, has two wheels, and so an algebraic expression with two terms. So a binomial has two terms. So you could think of something like 2x plus 7. So here's your first term, here's your second term. So this is a binomial. We could have 3x squared minus 6x. So you have one here, and then you have another one here. So this is also a binomial. So a binomial has two parts, just like a bicycle has two wheels. A polynomial means an algebraic expression with more than three terms. So a polynomial would be something like 4x cubed plus 2x squared minus x minus 2. Because it's more than three terms. There's actually, excuse me, we should put something right here called a trinomial. And if you think of this, you can probably get, because the word tri, like a tricycle, has three wheels. So a trinomial has an expression with three terms. So a trinomial would be like 5x minus 2y plus 4z, because it has three terms. So we have monomial that has one, binomial that has two, like a bicycle has two, trinomial, like a tricycle, has three wheels, so trinomial has three terms. Anything more than three is just called a poly. So polynomial. So poly means like many sides. So think of like a polygon is a closed shape with many sides. And so a polynomial has to have more than three. If it has one, it's a monomial, two, it's a binomial, three, it's a trinomial, and anything more than 3, 4, 5, 6, and beyond is called a polynomial. So why should I even care? So why are we even doing this? And I talked about this a little bit in class, and these are kind of foundations and building blocks of what we're heading into with quadratics. And so we're a couple reasons why we even care to be able to manipulate and simplify monomials, binomials, polynomials, trinomials, and all that. And so here are three reasons I think that you should care about this. And SpongeBob is helping me show you these three ways. So the first way is that we should always just know how to simplify math expressions and equations. It's a skill that you should just have. You should be able to combine like terms. You should be able to distribute. You should be able to simplify, because it's a skill in math that you should have in general. It will make evaluating easier. So if you had some huge, let's say, polynomial, and I asked you, what is this, evaluate this expression when x equals 3, and you have all these terms, but you could simplify it. Maybe you could combine some terms or multiply some terms, and you could simplify it first. It would be easier to evaluate that expression or equation. And it's also going to help us identify roots or zeros when we get further along. So by multiplying or adding or subtracting, we are going to maybe be able to form a quadratic or form some type of an equation where we can quickly identify or calculate the roots, the zeros, the min, the max. It's going to help us really be able to tell a lot about the graph that that equation or expression would produce. And just a quick reminder, when we're talking about zeros or roots, those are where the graph hits the x-axis. So if I have this right here, these would be my zeros or my roots. Because, oops, sorry. Okay, so let's think of the different ways that we can simplify polynomials or binomials or whatever nomial we have. So one way to simplify them that you're going to see is that we're going to be asked to add them. What's really cool about addition is that we are able to drop or eliminate the parentheses because you can add in any order. So it doesn't matter what order you add in when you're adding, you can add in any order. So you don't have to add in the parentheses first and then add anything else. So really we don't really care about the parentheses. So we're able to drop them. Once we drop the parentheses, we are going to combine like terms. So CLT stands for combine like terms. Okay, so let's look at this first situation that we have here. So we have 2x squared plus 3x plus 4x squared minus x. And so we are adding two binomials. And so we have this first set is a binomial because it has two terms, and then we're adding it to another binomial because that has two terms. So we are going to follow the directions right above here to simplify this expression. So our first step says that we're able to drop or eliminate the parentheses. So let's just write this without any parentheses because we don't need them, because we can add in any order. So it doesn't really, we don't need the parentheses to add in a certain order. The next step says that we need to combine like terms. So what I do is I like to box my first term and anything that goes with it. So I need any other x squares. So I have positive 4x squared. So these two terms in this green box, they are like terms because they have the same variable with the same exponent. Yes, these two terms right here have the same variable x, but they don't have the same exponent, so they're not able to combine them. So with my x squares, I have 2 plus 4, so I have 6x squared. Then I have 3x and minus x. So 3 minus 1x, 3x minus 1x still leaves me with 2x. So my final simplified form of adding these two binomials is 6x squared plus 2x. So I want you to use the same two steps, drop the parentheses, and then just combine like terms. And I want you to figure out this problem here, and I'll check your answers after you're done. Okay, so let's move on to if we are asked to subtract. So our first step is this does matter because we cannot subtract in any order. So think of it really fast. If I have 5 minus 3, that gives me 2. But if I have 3 minus 5, that gives me negative 2. So we're not able to just subtract in whatever order we want. We have to actually subtract in the order that it is given. So for this situation, we have 7x squared plus 4x. And we want to take away everything in these parentheses. And so we talked a little bit about this in class where we're going to distribute this negative sign. So we have this negative. This is we're going to distribute this negative sign. So it's distribute the negative, drop the parentheses, then combine like terms. So let's distribute this negative sign. So I have a negative to a 4x squared is going to give me negative 4x squared. And if I have a negative to a negative x, that's going to give me a positive x. So I'm able to drop those parentheses now, and now I can combine like terms. So I'm going to square my first term. So I'm looking at anything that I can combine with that has the same variable x with the same exponent of 2. So I see that I can combine it with this. So I have 7x squared minus 4x squared is 3x squared. My next term is 4x. Any other x's I have right here. So 4 plus 1 is 5x. So this simplified subtraction of binomials is 3x squared plus 5x. So if this was on a test and it said, which of the following are equivalent to this original situation, we would distribute that subtraction sign, drop the parentheses, combine like terms, and we would realize that this is the same thing. If I graphed both of these, if I set both of them equal to y and I graphed them, they would create the same line. If you don't believe me, you can pause the video and head over to Desmos, graph both of them, set them equal to y, graph both of them, and they will give you the same line. So just like when we were adding, I want you to take these 2 steps and I want you to work out this situation down here. Pause the video. Let me check your answers before you move on. I want to make sure you have addition down. Let me check. When you have addition down, you can move to subtraction. When you have subtraction down, we can move on to the next one. So the third way that we need to understand how to simplify polynomials, you have 2 options. We're talking about multiplying, and this is probably what you're going to see the most. And so we have 2 options on this. We can FOIL or we can use box method. So I actually have this same problem twice, and I'm going to show you the 2 different ways how you get the same answer. So for the first one, I want to make sure that we understand what FOIL, and you might have heard this before in middle school, but I want to make sure you understand what it stands for. So FOIL, F stands for first. So you're going to multiply your first terms. The O stands for outside. The I stands for inside. And the L stands for last. First, outside, inside, last. Or first, outer, inner, last. However you've heard it before. And then we have box method, which I'll explain here in a second. So let me show you with this first example how to do this with FOIL. So with my F, it means I'm going to multiply the first. So I'm going to take the first term and multiply it with the other first term. So 2x squared times 3x squared. We practiced multiplying with exponents earlier and before this, so we should understand that we take the 2 times the 3, and that's 6. We keep our base. This means I have 2 x's, and this means I have another 2 x's, so I have x to the 4th. Then you're going to multiply your outside terms. So you would have the 2x squared and the negative x, because those are your 2 outside terms. 2x squared times negative x. This actually has a 1 right here, so that might help us visualize it better. So we're going to multiply the 2 times the negative 1, so that's negative 2. I'm going to keep my base of x, my variable of x. This means I have 2 of them. This means I have 1 of them, so I would have 3 total. Then I'm going to multiply my inside numbers. So 5x times 3x squared. Because I'm multiplying, they don't have to be like terms. I don't have to have the same base of the exponent. And we've done this a million times, so you can multiply anything. When you're combining like terms, like you're adding them, they have to have the same base and exponent, because you have to be adding this, you're talking about the same thing. So again, so we're on the inside. So my blue pencil shows you the first terms in each binomial. My red shows you the outside terms. My green now is showing you the inside terms. So 5 times 3 is 15. We're talking about the variable x. I have 1 exponent here and 2 here, so I have 3 total. And then finally with my yellow, we're talking about last. So I'm going to multiply my last terms. So I have 5x times negative 1x. So I have 5 times negative 1 is negative 5. I'm talking about the variable x, and I have 1 here and 1 here, so I have 2 total. So let me just write this out. So I have 6x to the 4th minus 2x cubed plus 15x cubed minus 5x squared. My last step is that I want to combine like terms. Maybe you write that up here. Combine like terms. You always combine like terms. So I'm going to square my first term and see if I have any other x to the fourths. And I don't, so I can keep 6x to the fourth. And then I'm going to put a circle around my next term. And I want to see if I have any other x cubes. And I do. I have 15x cubes. So I have negative 2 plus 15 gives me 13 x cubes. And then I have this last term of x squared. I don't have any other x squares, so I can just subtract 5x squared. Again, if you put this original equation, set it equal to y, and you took this one and set it equal to y, you would graph the exact same line. If you want to pause the video and go look at Desmos, you can see that they're exactly the same, which is the point of doing this. So if you're taking the AIR test or you're taking a test and it asks you to simplify or asks you if these two expressions are equivalent, you can graph them and they should get the exact same graph. They should get the same shape, same line, same y-intercept, same x-intercept, same everything. Okay, so let's go down here and do the same problem but using box method. So box method's pretty cool, and I think it's one thing that you might like a little bit better. So what we're going to do is you're going to draw a box, and you need however many terms you have in your first set, you'll need that many boxes across, and however many terms you have in your second part, you'll need that many boxes down. So I have 2 terms this way, so I'm going to have 2 boxes across, and I have 2 terms this way, so I'm going to make sure I have 2 boxes down. So it's a 2 by 2 expression, so I have a 2 by 2 box. Then you're going to put your terms on the outside of your box. So for this first set here, I'm going to put on top, like that. And for the second set here, I'm going to put along the side. Making sure that this sign goes with the variable. So you have to make sure that if you have a negative, it needs to go with that variable that's after it or that term that's after it. And then all you do is you fill this in like a multiplication table. So if you guys remember from when you were learning multiplication, maybe in elementary school, you would put your finger on 2 and put your finger on 7, and then wherever they meet, that would be 2 times 7, which you would see 14. So I'm going to take this term and this term, and I'm going to multiply them and put them in this first box. So 3 times 2 is 6. I'm going to keep x, and I know I'm going to add my exponents. So 6x to the 4th. This next box, I'm going to have 5x squared and 3x squared. So 5 times 3 is 15. I'm going to keep x. And if I have 2 in the red and 1 in the blue, I have 3 total. For this bottom left, I have negative x times 2x squared. Well, this is negative 1, remember? So I have negative 1 times 2, which is negative 2. I have x. If I have 1 red x and 2 blue x, I have 3 total. And then for my last box, I have negative x squared and 5x. So negative 1 times 5 is negative 5. I'm talking about x. I have 1 in the red, 1 in the blue, so I have 2 total. Once you have your box filled in, you're just going to write it as one long situation. So I have 6x to the 4th plus 15x cubed minus 2x cubed minus 5x squared. So I just went through and wrote all of these in one long expression. If you look at the top, I have exactly the same thing up here. I have 6x to the 4th, positive 15x cubed, negative 2x cubed, and negative 5x squared. So we already know that we're doing this correctly. So now your last step is to combine like terms. So I'm going to box my first term and anything that goes with it. I have no other x to the 4th, so I know that this is just by itself, 6x to the 4th. My next term is 15x cubed, and I have negative 2x cubed that I can combine with it. So that gives me 13x cubed. And then last, I have this x squared. I have no other x squared, so I just need to leave it at negative 5x squared. Don't forget that this negative sign goes with the term after it. So this is my final answer, which is exactly what I have right here. So hopefully that shows you two different ways you can multiply. So you can use FOIL, and you're just basically doing double distributive property. Or if you have 3 in the first one, you're doing triple distributive property. The second one is to use box method. And I'll show you more of box method. I like that way better. I think it gives you a better visual of what you're doing. And I'll show you some FOIL and some box method in the walkthrough. But if you feel completely lost on that, I want you to go back through and watch the video again and really try to pay attention to what I'm doing and what I'm saying. So this is the end of our notes. Make sure that you do these two problems with adding and subtracting. Make sure that I check them before you move on to the walkthrough. Okay, see you in class.